All right, CNT140, we're working on Chapter 8. This is our second podcast, so we're picking up where we left off. Um, the next thing they talk about with our access points, they mention a couple more details. They talk about the access points connecting to a wired network, requiring a cable network connection, and needing uninterruptible power. Let's examine all those thoughts, okay? First thing, I go back to our map that we had previously. Our access points do need to connect into the wired network. Absolutely. So if I think back to our cabled structure we talked about before, closets, backbone cabling between, typically fiber, copper cabling out to workstations, well, I'm going to run copper cable out to workstations to outlets on walls and so forth. The same thing's going to happen for access points. I'm going to run a wired connection out to an outlet or outlet box that's above the ceiling for my access point. No difference. So again, here's my sample access points. If I look a little closer, if I flip them over, if I take this guy and flip him, or actually, if I take this guy and look at the specs on him, it talks about it's capable of G and N and all that good stuff, and they say, hey, there's an RJ45 connection. Well, if I flip that access point over and zoom in, I'll see there is a port for console, just like console into a router or switch for configuring, and I also see an Ethernet connection here. Yeah, that's for the access point to plug into the network. And what I would typically do is instead of running a cable down the wall to an outlet box for a user, I just run a cable to an outlet box above the ceiling that my access point plugs into, and I use a patch cable to go from the access point into that network drop. So it's really no different as far as connecting. I'm just plugging an access point in instead of plugging in a computer. My access points are typically going to mount to the ceiling in some manner. If I look at a suspended ceiling, they actually make brackets that anchor on the suspended ceiling, and they snap up into place. Some of them even have little locks on so they don't get stolen. So I will mount into the ceiling, and then I run a cable from there up through the ceiling up to that network drop. There is actually little units that can be installed in the ceiling that my access point anchors into, and then this closes and latches shut or locks shut. And then there actually is points here where the antennas connect out to these little lugs in the ceiling. And then here's one that is actually a box that kind of covers the whole thing and anchors or locks in place to protect the access point from accidental damage, theft, that sort of thing. So there's my access point and my mounting and connecting the network. Absolutely. The next thing they mentioned was uninterruptible power supply. Yes, typically I'm going to power my access point through power over Ethernet. So from my switch, it'll use the unused data wires to power the access point. Okay, so hopefully you remember this from talking about it previously. Many switches are capable of power over Ethernet. Here's a couple small switches. Here's an 8-port that shows you these ports are power over Ethernet. Here's a this guy's like a 24 port. These ports over here are capable of power over Ethernet. And if I look even closer on some of them, they'll even show you that these are link lights, and then these is showing you that if something's plugged in, is it powering? So there's a little light showing that this particular port is actually providing power to something, camera, access point, whatever. I'm also going to remind you, as you look at switch specifications, if I were buying a Cisco 3650 switch, here's a 24 port and a 48 port that do not have power over Ethernet. Yet here are model numbers down here that are capable of providing power over Ethernet. And if I keep looking, they will even tell you how much wattage it's able to support. That would be part of the homework you need to do to support phones or access points in a network. So I select my switch model knowing how much power there is, and I do a little homework on how much power my access point uses. I pulled up a relatively common Cisco access point, and I look at the specs and says it's going to require 15.4 watts of power to power the thing. So then I do my homework saying, okay, if I buy this switch model number, it's able to support 390 watts. This uses about 15 watts. Math tells me I can support about 25 access points on this switch. And if I try to plug 26 or 27 access points in, those last couple access points will not power. Okay, so that's just kind of a little side note on power over Ethernet. But going back to what they said, my access point is going to be powered from my switch. That way, the access point can be located in an area with best coverage and not have to worry about plugging into an outlet, electrical outlet. That's the reason I would be doing that. Okay, so there's our uninterruptible power coming from the switch in the closet. And actually what I didn't think to mention earlier, but I'll mention now, is this switch in the closet is typically then backed up with a UPS unit. An uninterruptible power supply is actually providing power to that switch. So my access points are being powered through power over Ethernet from the switch. Then the switch itself has battery backup, if you will. That's a typical install. Okay, so when they talked about those issues there's how those are addressed or typically tackled, if you will. Then they go on to talk a little bit about how these wireless networks work. First thing they mention is that they use electromagnetic waves, and the data itself is superimposed on that radio carrier frequency, and that's called modulation. Okay, well, first thing we need to remember is our electromagnetic spectrum. Here's our whole electromagnetic spectrum, from gamma rays, X-rays, ultraviolet, visible light, infrared, down to our radio spectrum down here, this part down here. In our radio spectrum, yes, we do have AM radio, FM radio, television, when we still had, most people were still getting television through an antenna, okay? But in there, in our gigahertz range, in our 2 to 5 gigahertz range, actually it'll be more up here, I'm sorry, I'm drawing right here, in this little slice of the frequency band are our wireless access points or wireless networks, along with things like cordless phones and that sort of thing. So that range of our radio frequency band is where our wireless network communication occurs. And if we hopefully also remember from 120, we talked about different types of modulation. If I take and modify the amplitude of a waveform, there's my carrier signal. If I modify the amplitude of the waveform, I get amplitude modulation, or AM radio. So if I'm altering the amplitude of a signal to carry data, that would be amplitude modulation. If I take, here's my data, here's my carrier signal. If I take and alter the frequency of my waveform, higher frequency, lower frequency, higher frequency, lower frequency, I'm carrying the data using frequency modulation. If I take and alter the phase of a waveform, here's my data, 1010, here's my carrier frequency, and I cause a phase shift where it starts to go here and it kind of like jumps 100 degrees out of phase and goes this way, and then jumps 180 degrees out of phase and goes this way. Now I'm using phase modulation. Well, we mentioned those in 120 to get you thinking, if I'm going to carry data, those are different ways I can modulate the frequency to be able, or modulate the signal to carry data. So as I look at wireless networks, we are using pieces of these technologies to carry data across a wireless signal, across this radio band, if you will. That's the kinds of things that are going on. Okay, so that's how my data is carried across the radio waves from an access point out to a NIC and vice versa. They then remind us that our access points connect to a wired network using Ethernet. Of course, yes. So again, here's my access point connected through a wired connection back to an Ethernet switch. And this access point, here's another picture I pulled up. This access point almost acts like a bridge between wireless signaling and wired signaling. Okay, well, let's put some pieces together that we know. Our wired Ethernet over here, okay, wired Ethernet is using CSMA CD. That's my 8023. It's using that frame formatting. It's using that access method to move data around the network. Well, my access point is connecting to wireless users out here, 802.11, that are using CSMA CA framing and access method to communicate. So my access point almost acts like a little mini bridge. You notice I put that in parentheses or in quotes. It's not really a bridge, but it's kind of acting like one. That the 802.11 framing of CSMA-CA is able to be communicated and converted into CSMA-CD framing for wired Ethernet network. Okay, and that's what they're getting at when they talk about APX connects to the wired network using Ethernet. That's what they're getting at. That's the significance of that. That's the important piece of that puzzle to remember. We have wired Ethernet and wireless Ethernet, if you will, and they are 802.11 and 802.3. It's a slight change between the two to get them communicating, and that's the role of our access point, acting almost like that bridge, and I'm putting air quotes around it, between the two. The radio signal communication distance is a function of the system design. Yes. As we look at our standard, they remind us that the approximate range for a standard wireless network for A, B, G, and AC are this distance indoor, and that is, kind of like in a good sense. Things like walls and filing cabinets and desks and plants are all going to affect that and reduce that range. And this was a picture we had back in, I think, 120, when you're in your 120 book, showing you that an access point here, all kinds of things like walls and tables and chairs and plants and filing cabinets and metal studs in the walls are going to affect how that signal is propagating. It might reduce the signal. It might actually bounce it and help it go down the hall further. These all affect the range, the effective range of our wireless network. And again, don't forget our antenna. Our antenna plays a role in the functional range of a wireless network too. So the whole dipole, patch array, directional all affect the range, the effective range of our wireless network. They remind us that the infrastructure costs depend on the number of access points. Of course, the more area I need to cover, the more access points I'm going to need. It's going to be more costly. I need more cable drops. I need more access points. I need more antennas. I need more of those boxes in the ceiling to anchor the access point in. Yeah, it's going to cost more money to do that. So I'm going to show you a couple examples of things like heat maps that get created. This is one from Netgear showing you access points in a building, showing you the approximate range of these. Obviously, the more area I need to cover, the more access points I need. It's going to cost more money. But there's tools out there to help you approximate how many you need and what kind of area they're covering. And your better access points even allow you in many cases to crank up the transmitting power to get more range, or dial it back to have less range. And those are some fine controls that you usually have in access points to either get more area with an access point so you have less of them that you need, or dial it back so you have less people connecting because it's not covering as much area. And here's yet another one showing you, in this case it's actually showing how many clients are connected in each area. So there's tools out there to help you figure that out. All right, I'm going to pause here. When I come back in the next one, we will continue on.